So let's look at the function for the non-maximum suppression. We have seen this in post 3. So I'm not going to describe in detail about this non-maxima suppression. You can refer the videos, the respective videos in post 3 for this, where it's been described. So as the function says, it looks at all these overlaps between these bounding boxes and only take where the overlap is minimum, so as to get to minimize the number of overlapping bounding boxes. That's the function, or that's what the non-maximum suppression algorithm does. Maybe I'll some of the parameters here. So this ratio between how much these overlap happens, this is something which you can alter and then see what is the effect of it. So here I've defined an overlap ratio of 0.4. so what it means is only if it is more than 0.4 you are excluding those bounding boxes. So if the overlap is larger than 0.4, we are excluding that. Any overlap lesser than 0.4, we keep those bounding boxes. So you can alter this specific play around with this ratio and then find out what effect there is. Okay, so other than that, these function is the same as what we have implemented in the post 3. So now once we do the maximum non-maximum suppression, so we get so we are applying this non-maximum suppression function here to all those boxes. So remember, we had 395 boxes after we filtered out based on our probability threshold, and finally by applying non-maximum suppression, it gets reduced to just 5 of them. So that's the effect of non-maximum suppression. So let's look at how good these those non-maximum suppression bounding boxes. So let's clone the image again. So this is the original image. So you can see there is this whole region where there are potholes here, and there is some region here also. So let's see how well the non-maximum suppression has worked here. So this is it. So you can see that it's pretty well represented. So there is this big box here around this whole region. So which is what we want. So let's look at a company who wants to identify which are those places, the area in which it has to look for potholes, and then so that it wants to do a repair work. So obviously you'll have to look at this complete area, because it's all potholes are there, and then it's all broken down here. So you will have to look at the complete area where you will have to repair this. Similarly, these areas, there are another pothole, and here this region is also pothole, but other regions, probably these are all misclassification, because you don't see a potholes. Maybe just these lines have been taken as potholes. We are not too sure whether that's a pothole or not, but it looks like maybe a crack in the road. So we can give the benefit of doubt to this. So as you can see that our algorithm has kind of localized the pothole into the right region, and which is actually good. So that takes us to the end of this these implementation of RCNNs.